Hi everyone. Today I'm going to explain concavity in the second derivative test. First, let's remember that the first derivative tells us if a function is increasing or decreasing and help us find the maximum and the minimum point. Now, the second derivative help us understand the shape of the graph, which is called concavity. If a graph is concave up, it looks like a ball opening upward. If it's a concave down, it looks like it's upside down. A point of inflection is where the graph changes concavity, meaning it goes from concave up to concave down, or the opposite. To find all of this, we first take the second derivative, we set it equal to 0, and we test the value around it. We see if it's negative, it's going to be a concave down. If it's positive, it's going to be concave up. Let's first work on this example. It's a really simple example, so that's going to help us remember all the stuff that we go through. First, we take the first derivative. It's gonna be 3x, and we set the exponents minus 1, so it's gonna be 2. To take the second derivative, which is gonna be, we take 3 down, and we times it to the exponent, and we set the exponents minus 1. It's gonna be 6x. After we found the second derivative, we set it equal to 0. Let's give us 6 equals 0. This is a possible point of inflection. Now the second step is test the value around it. So we're gonna draw a line and we're gonna plug in 0. We're gonna take a point from left 0 and the right side. Okay, we're gonna see the first one on the left. We're gonna plug in -1 to the second derivative. It's gonna be 6 times -1 equal -6. It's negative, and the other one is gonna be positive. Since the sign changed from negative to positive, this is a real point of inflection at x equals 0. So we have concave down from negative infinity to 0, so it's gonna be like this, and we do have a concave up on 0 to positive infinity. So we're gonna write it down. We make sure that we always write down the intervals. So this example was only to show the steps. Second problem, I took it from the test, so can everybody remember how we do this one step by step, since the teacher gave us a chance to retake the test, so that's gonna help. And do it again. So we're gonna first take the first derivative. It's gonna be 2x squared plus 2 4x. We know that we have here quotient rule, so we're gonna just follow the rule, which it says f prime x equal So we're gonna just follow the rule. We know that f of x it's 2x squared plus 2, and g of x it's 4x. The derivative of the first one is gonna be 4x, and the other one is gonna be only 4. So now we're gonna just plug everything in. So we're gonna have 4x times 4x minus 2x squared plus 2 times 4 over 4x squared. Now we're gonna just do the algebra. So the final answer is going to be 8x squared minus 8 over 16x squared. Now we're going to take the second derivative. It's going to be, we're going to follow the same steps. It's also quotient rule. So we're going to take the first derivative of the 8x squared negative 8. It's going to be 16x. And then gx equals 16x squared. So g prime is going to be x. Now we're going to do the same rule. So second derivative is going to be now we're gonna just do the algebra to calculate everything. Now we're in this step, we're just gonna cancel and simplify everything. So the second derivative gonna be 256x over 16x squared. Now we're gonna set it equal to 0. So again, we did have a situation where x equals 0, and also it's possible point of inflection. So now we're gonna just test the value around 0. We're gonna plug in -1 to the second derivative. So it's gonna be negative. And then f of 1 gonna be positive. Here we don't care about math, we just care about the sign that's gonna be at the end. Here we're gonna know that it's a point of inflection. It's gonna be increasing and decreasing. So it's minus here and then it's plus here. So now we have concave up from finish to 0. So that's gonna be the answer. Hopefully this video help you a lot to understand the step by step how's everything going, and thank you so much for watching.